Hi, my name is Manpreet Singh. Today I'll be talking about teaching strategies in STEM for children in early years. First of all, introduction. STEM refers to National Science Foundation's educational initiative in science, innovation, design, and mathematics. STEM is seen by a few teachers as any of the STEM fields. Others, on the other hand, believe that some but not all of the disciplines will be integrated in order to complete STEM assignments. The foundation of STEM education begins in a child early years. Gersten and Chard in 1999 believed that number sense motions are important to early science advancement as phenomic awareness principles are to early reading. Understanding of computation and estimating is also viewed as important, useful for children in their formative years. Now, talking about teaching strategies in STEM. Early science and math begins with four fundamental showing rehearsals. First of all, intentional teaching. Second is teaching for understanding. Then comes encouraging inquiry. And last one, providing real world context. Inside the STEM disciplines, deliberate showing means that instructors thoughtfully arrange chances for advancement in light of scientific and math. When it is time to fit, they utilize innovation as learning tool and establish connections with design. Learning objectives should be centered on perceiving so that students can apply what they have learned in science and math to new situation. It's reference to Murphy in 2019. Math and science both are inventive fields in which individuals seek answers to important questions, make connections, and communicate their ideas. As a result, a focus on requests should be at heart of education in both areas. Small children learn best when they can connect with tangible and established connections to personal experience. Now comes intentional teaching. As with all areas of curriculum, children learn more effectively when teachers incorporate developmentally appropriate practices when implementing activities in STEM disciplines. The third edition of developmentally appropriate practice in early childhood program serving children with British through age 8 emphasizes the importance of intentionally teaching. This means that effective teachers are purposely in all aspects of teaching. They plan the curriculum and environment with specific outcomes and children in mind. They remain alert for teachable movements as they occur throughout the classroom. Effective teachers understand the development and learning trajectories for children in each area of the curriculum. They also know what individual children understand based on child's development. This knowledge allows teachers to plan a multi-level curriculum that meets the learning needs of a range of children. The teacher can intervene as children interact with materials to structure learning for each child. Also, they keep their eyes peeled for usable minutes occur throughout the study. As children interact with items, instructor may intervene or help. Teaching for understanding. In its principles and standards for school mathematics, the National Council of Teachers of Mathematics addresses effective teaching practices through its teaching and learning principles. Emphasizes The teaching principle emphasizes the mathematic teachers understand know, what students need to know, and how to support students in their learning. This principle applies equally to students in their learning. The principle applies equally to teachers of preschool through high school. Teaching for understanding is a focus of all of the activities in this book. The learning principle, which also relates to development, focuses on the importance of learning mathematics with understanding. Regardless of age, students use their prior knowledge and experience to construct new knowledge. Conceptual conceptual understanding of mathematics is critical because student can then use their mathematical knowledge to solve new problems. Learning at the conceptual level rather than simply memorizing fact is equally important in science education. In both mathematics and science, teachers should encourage children to solve problems through their own thinking rather than supplying them with answers. This allows children to build upon their previous knowledge and depend on their conceptual understanding. The following example from a preschool classroom considering a STEM activity because it incorporates both science and math. Now talking about encouraging inquiry. The National Science Education Standards as developed by the National Research Council 1996 emphasizes that inquiry into questions generated by students should be the focus of science teaching. This does not mean the teacher never introduces a topic for study. Nevertheless, the teacher should determine what question children have about a topic and provide support as they experiment and determine answers to their questions. Again, this emphasis on inquiry extends to the youngest learners. Lifelong scientific literacy begins with attitude and values established in the earliest years. Likewise, inquiry should be a guiding force in learning mathematics. As children interact with material, they form relationships such as grouping objects into various categories. This indicates that they have developed a general rule to govern placement of items, an important algebra concept. As an example, children may decide that all large animals should go into one field and all smaller animals should go into another field. Now, providing real world context to children. Each of the all of the examples used previously in this chapter involved children engage in everyday experience such as playing and eating. Young children learn best when activities are relevant to their lives. In science, it is particularly important that young children have real materials to explore because that because preschoolers and kindergartens are still determining the difference between reality and fantasy by observing a classroom goldfish. Children may notice that this is a real life example, does not behave at all like fish in popular storybooks. Similarly, the rabbits at petting zoo don't wear coats with gold buttons and drink tea. Experiences with living plants and animals can spur discussions about differences uh, discussions about differences between real and pretend. Likewise, in a physical science, children need to interact with material, experiment, and observe the results. This helps dispel notions that scientific process are magical. While a car viewed in a video game or on a cartoon show may jump vertically or fly through air, the cars children use on the ramp that they have constructed in the classroom behave in consistent or predictable ways. Conclusion. Now I would like to conclude my topic. After a decade of intense focus on literacy development in early childhood programs, attention is now shifting to importance of early learning in mathematics and science. STEM education integrates learning in both of these disciplines and includes connections of to technology and engineering by focusing on connections between science and mathematics. Teachers can accommodate curriculum goals and learning standards in both disciplines while helping children understand the ways in which mathematics and science are woven into their daily experiences. Attached are the references. Thank you so much. Have a good day.